Hello guys, welcome once more to another video in our YouTube channel. So in this video we are going to be looking at physics. We are going to be looking at a question on circular motion. So if you're just joining us in this channel, endeavor to subscribe to the channel, turn on your notifications so that whenever videos are uploaded you'll be notified to come and watch. So let's get started. Alright, so the question reads, figure 1 shows a mass 2 kg attached to one end of a string of length 1.1 meter and wheeled in a horizontal circle. Calculate A, the tension in the string, B, the period of revolution of the bob, and C, the tangential velocity of the bob. So here is a diagram displaying what is happening. We have a ball. Okay, it is wheeled, it is attached to a string, and the string makes an angle of 30 degrees with the vertical. It is wheeled round, wheeled in a horizontal circle. Okay, so the ball describes circular motion. So you have the radius of the path, and you have the length of the string that was also given to you, and you have the mass of the ball that was given to you. Okay, so the first question is asking us to find the tension in the string. So to get a tension in the string, we are going to resolve the forces that are acting on this mass, okay, in both vertical and horizontal directions. So we first of all have the tension, which is acting, the tension acting on the string. We can call that tension T. But since this tension is acting at an angle with the vertical, it means that the tension has components in the vertical and in the horizontal direction. So the component in the in fact, before going to the component in the vertical and horizontal direction, we first of all have the weight of the ball, or the weight of the mass is mg. Since m is 2 kilograms, it means that the weight is going to be 2g. This g here represents the acceleration due to gravity, which in this case you are going to use 9.8 if needed. Alright, so we have the weight as 2g. Now if we resolve this tension into its horizontal and vertical components, we are going to have the vertical component of the tension to be T cos 30 and the horizontal component of the tension to be T sin 30. But what actually keeps this mass to be moving in this horizontal circle is what we call the centripetal force, which is always acting towards the center. I can call it F. Now from here, now we can now get the tension in the string. So the first part of the equation says we should find the tension in the string. So in the course of the motion, you realize that the forces in every direction are supposed to be balanced, okay, so that the the mass should not leave the circular path, it should continue moving in that circular motion. So the forces being balanced, the first thing is that the vertical component of the tension should be equal to the weight of the mass. So T cos 30 is equal to 2g. From there we can get the tension directly. So the tension is 2g divided by cos 30, which is in fact I just use 10 for g. So T becomes 2 times 10 divided by the square root of cos 30 is root 3 on 2. You could also use 9.8. okay, I don't know which one, but anyways, I think 9.8 is the best choice to use. It's just that when I was doing the solutions, I just put 10. But like I said, that's why it's not simplify the answer. So you could also use g to be 9.8. I think it's preferable to use g to be 9.8, okay, since it is physics. But when we get to math mechanics, we always use g as 10. So here, try to correct this. The g is 9.8. Alright, so when you simplify this with 2 times 9.8 divided by root 3 on 2, you get the value of the tension. Now we also have that for this mass to continue moving in this circular path, then the horizontal component of the tension must be equal to the centripetal force, because the centripetal force is a force that keeps the motion in, that keeps the mass to continue moving in the circular path. Now the second part of the equation is asking us to get a period of revolution. The period of revolution. So we know that period is 2 pi divided by omega, where omega is the angular velocity, and to get omega, we must use the centripetal force. So having the fact that T sine 30 is equal to the centripetal force, and the centripetal force is basically the mass times the centripetal acceleration, and the centripetal acceleration is omega squared r, where omega is the angular velocity and r is the radius of the path. I've replaced the mass already with 2. So you have T sine 30 to be equal to 2 omega squared times r. Alright, from there now, what is omega squared? It is, I divide both sides by 2r, so I get omega squared to be T sine 30 divided by 2r. Now, in fact, I just simplified this tension here to 40 on root 3. But like I said, guys, it's preferable to use 9.8, okay? Though I use 10, but I plead that you use 9.8. So we have omega squared to be 40 on root 3 times half, because sine 30 is half, and the tension has been simplified to 40 on root 3, then divided by 2r. Now we need to get the value of the radius of the of revolution. That's the radius of the path, okay? We need to get the value of the radius of this horizontal circle. In fact, if we further simplify this, we get 20 on 2 root 3, because 40 on 2 is 20. Alright, now how do I get the radius? You realize that we have an angle. In fact, you clearly see a right angle triangle here, right? We have an angle of 30 degrees. We have the opposite to the angle is a radius, and the hypotenuse of the angle, or of the right angle triangle, is basically the length of the string that was given to us as 1.1 meter. So if we use sine of 30 degrees, we need to get the opposite, which is the radius, divided by the hypotenuse, which is the length. So it means that the radius becomes the length times the sine of 30 degrees. The length is 1.1 meters, and the sine of 30 is half. That's why I have 1.1 meters divided by 2, which gives us 0.05 meters. We just need to replace into the formula here. So omega squared becomes 20 divided by 2 into 0.05 times the square root of 3. So all you need to do is to simplify. When you simplify, you get the value of omega, okay? Because omega squared will give you this. You need to take the square root on both sides to get the value of omega. Once you get the value of omega, you now get the period as 2 pi divided by omega. You get the period. Make sure you comment, you give your answer in the comment section, so that I should tell you if it is correct or it is not correct. Alright, now the last part of the equation is asking us to get the tangential velocity of the bulb. So the tangential velocity is v, which is just basically equal to omega r, where omega is the value you're going to get here, that's the angular velocity, and r is the radius, which we have calculated as 0.05. okay? So directly you can multiply the omega you're going to have here after taking the square root on both sides with the radius, which is 0.55. You get the tangential velocity. Alright, thank you for watching, guys. See you in the next video. Make sure you like, you share, and you subscribe to our YouTube channel.